Okay, so I will start now. So, hello guys, I'm Rajesh from Department of Computer Science and Technology, second year, IIEST Shipper. So today our agenda is to learn the two-pointer method. Okay, two-pointer is a problem-solving technique which usually helps uh, to solve the problems in an efficient way. Okay, without two pointers also we can solve those problems, but if we use them, so then we can do that in an efficient way. So let me share my screen. So is that visible screen? You can reply me in the chat. Okay, fine. So our today's agenda is going to be this. So first let's see what is two pointer and what we actually do in two pointers, and then let's discuss about merging two sorted arrays. This method will actually help you in many other problems also, not exactly this. Uh, and let's discuss other problems, two sum and three sum, finding the middle of a linked list. And also there is a problem from code forces that is called paired programming. Let's see that also. Okay, this is going to be our agenda today. Okay, so let me start with what is two pointers. So the basic idea of two pointer is we will take two variables. Okay, we will take two variables that suppose we have an array and we will take two variables that points to some locations, and based on some conditions we will manipulate them and use as we want. Okay, simply we can say this as manipulation of two variables and getting the required results. Okay, so let's discuss this more detail with the help of this merging two sorted arrays. Okay, merging two sorted arrays. How many of you have attended this sortings class that was taken by me, and how many of you heard about this? I mean, I already explained this how to merge two sorted arrays when I am discussing the merge sort. Do anyone attended that class, the sortings class, which where I discuss about sorting two, I mean merging two sorted arrays. I will discuss now also, but yeah, okay, Subhashish. Uh, let's take this thing. Suppose I have a two sorted arrays. Okay, 3, 5, 9, 13, and 19. This is one sorted array, and the other sorted array is 4, the 7, and 23. Sorry, not 23, because let's take this as 10, 15, and 20. So it has 5 elements. Let's take unequal elements to know more about this. 25 and 27. So this is the first array, and this is the second array, and the first array has a total of 5 elements, and the second array has total of 7 elements. Now we want to merge these two arrays such that the resultant array is also sorted. Our goal is to merge and resultant also must be sorted. Okay, so what is the brute force method that we can apply here is you can just concatenate both of the arrays and apply any sorting technique that you know, like merge sort, quick sort, or insertion sort. So how much time it will take? Suppose the size of the first array let be, I mean, m, and the size of the second array let be n. Then how much time it takes? Then the total length becomes m plus n, right? So based on the technique that you I mean based on the algorithm that you have chosen, it will take at least m plus n log of m plus n, right? This is the the best complexity that we can get in sorting is n log n, right? So if we apply the brute force method, that means just concatenating both these two arrays and then applying any sorting algorithm that we know. So that will the complexity of this is this. Can we do that in any other way or in any efficient manner? So we can do that by using two pointers method. Okay, so let me discuss that thing now. So what I'm doing is I'm taking two variables or namely two pointers. So let's call them P and Q. The P is pointing towards the first element of the first array and Q is pointing towards the first element of the second array. Okay. Now what is 3 here? 3 is the smallest element in the first array, right? And what is 4 here? The 4 is the smallest element in the second array. So it is obvious that the smallest of these two will be the smallest of the total array, that means after concatenation, because there is no element that is smaller than 3 after this 3. Similarly, there is no element that is smaller than 4 after this, I mean, in the second array. So whichever is the smaller of this 3 and 4, that is going to be the smallest of our resultant. So we will check which one is smaller in P and Q. Like now P is I mean, out of these two pointers, so one is pointing towards 3 and another is pointing towards 4. Okay, so here the smaller is 3, so we just added, this is our resultant, so we just added into our resultant. Okay, and then uh, as you have already added this 3, now move that pointer forward. Okay, now the pointer comes towards the 5. Okay, now P is here. Okay, uh, again what you have to do is you again have to check which one is smaller out of P and Q. Now P is pointing towards 5 and Q is pointing towards 4. Now what is the smallest in these? So the smallest is 4, so we add that 4 to our resultant and move this Q forward. Okay, so now Q is at 7, right? Now again you have to check which one is smaller and adding into the resultant. Smaller is 5, so now P comes here. Okay, uh, now which one is smaller? Now Q is smaller, so Q comes here and we have 7. Now which one is smaller? Here P is smaller, so I'm wrapping this up. Okay, you understood the basic idea, right? So this 9, and now which one is the smaller? 10 is smaller, so Q comes here. Now 13, so P comes here. Now 15. So out of this 19 and 20, 19 is smaller. So now here, till when we have to complete any one of the array is exhausted. So here we completed all of the elements in the first array. So there is no element to, I mean, point to P. Okay. Then what we can do, there is no need of comparing, and you can just add the remaining elements to the end of the resultant. So that will becomes 20, 25 and 27. So this is the resultant sorted array after merging these two arrays. Okay, so the condition is we need to compare these two pointers until any one of the array is exhausted. If sometimes both will be exhausted at the same, then you no need to concatenate the other things. If any one is exhausted, then the remaining one you need to concatenate at the end of the resultant, because there is no elements to compare with this 20, 25 and 27, right? So that's why. uh, is this clear, or any question or any confusion that you have, you can just ask me, or if you didn't understand, I will repeat it again. So this thing you understood, right? I already explained this when I'm explaining this merge sort. So but at this point, so we need to discuss about this 2 pointers, right? So I, yeah, so you guys understood about this, fine. So can you tell me what are the while loop conditions that we have to employ here? Okay, we have two arrays. Suppose two arrays are A and B. Okay. Now what I'm doing is I'm taking two pointers. So P and Q. Initially P is equal to 0, Q is equal to 0 because indices starts from 0, right? In the both arrays. This is array 1 and this is array 2. Okay. And the length of the first array is M and the length of the second array is N. Right. What will be the while loop condition that I need to mention here, and I need to continue this process? Can anyone tell this? So the question is, the length of the array, first array is M, the length of the second array is N, and I'm taking the 2 pointers P and Q. Both are initially at the first element of the arrays. So P is pointing towards the first element of A and Q is pointing towards this first element of array B. Now what I'm asking is, what is the while loop condition? Yeah, if P is less than N and uh, you just interchange. Okay. Yes, great, great. I got your point. So here what we need to do is, so this is what uh, P is towards the first and the length of the first array is M, right? So P less than M and uh, Q less than N. If these two conditions are there, then both arrays are not exhausted, right? If any one of the arrays exhausted, then one of these will become false. Then this while loop ends. Now, after completion of okay, what you have to do in this while loop? So you have to check if uh, P is in the first array, right? So if AP is less than BQ, then resultant dot pushback or append or anything resultant. So I'm just writing it as add. Here AP is smaller, so add this AP. Okay. Else the possibilities are uh, either this will be smaller or both of them equal. So if both are equal, I can add anything to my resultant, so that will not do anything to me. So I will just resultant dot add B of Q. Okay. Now when this while loop ends, what I need to check here? After this first while loop ends, there may be two cases. Both will be exhausted or any one will be exhausted. Then only this while loop ends, right? And one more thing here, I forgot to increase this P. P plus is equal to 1. Here, Q, sorry, P is equal to P plus 1 and Q is equal to Q plus 1, right? So this thing also I need to make sure, or else this will be an infinite loop. Check if P equal to M minus 1 or Q is equal to N minus. If any array is not exhausted, right? I need to make sure that no elements is remaining. So while P is less than M. So I don't know, either this may be false or this may be false. I am considering first this is false. So I'm writing this condition while P is less than M. So I don't need to check anything. Just add resultant dot add AP and P is equal to P plus 1. Now before this while loop only I can write this also. While uh, B dot Q and Q is equal to Q plus 1, right? Out of this and this, only one while loop will run, right? Because either any one will run or both do not run, because this while loop ends only if any one of the arrays exhausted or both of the arrays are exhausted. So I don't need to check anything like P is equal to M minus 1. We can just write any one of these two will run. Is that okay? What I wrote, is that clear? Yeah, result res is a vector, or you can say resultant array or anything. Okay, great. So not only here, if you understood this concept, you can apply this in another problems also. This very useful thing. Okay. Now, so what is the next thing that I want to discuss is this two sum. This is a very famous problem in lead code. How many of you have solved this problem? Sliding windows. I think it's not in the syllabus, but I will ask the team and tell you, Tathagata. Okay. So how many of you solve this 2.2 sum problem which is in lead code? Do anyone solve that? Okay. I think you don't know the question. I will explain. So see this. This is the two sum question. We are given an array of integers nums and an integer target. Return the indices of the two numbers such that they add up to the target. Okay. You may assume that each input would have exactly one solution and you may not use the same element twice. Okay. So do I need to explain this question or you got this? You can tell me. Okay, no got is right. So our main goal is to find the indices which sum up to the target. I mean, if we add the elements at that indices, the resultant, I mean, the sum must be equal to the target. They're saying that there exists exactly one solution, but it may be possible that they can ask this also, like uh, we want to give all of the possibilities as an output, but yeah, both, if we know this, we can do that also. That's not a difficult task. Okay. Uh, you may not use the same element twice. That means we are suppose the target is 4 and we found an element 2 and we are saying I can add this 2 twice and get the answer. This is not correct. You have to choose two different indices. So that's an here constraint. So is that sorted array? They did not mention it, so we need to sort it explicitly, right? See, do they mention that? Given an array of integers nums, okay, that's it. And in the constraints also they didn't mention that the array is sorted or not. Okay, so we don't have to consider this is sorted. We need to explicitly sort this if it is required in the solution. So what is a brute force thing that we can apply here? Can anyone suggest what is the brute force method that we can apply here? Yeah, two loops. Great, great, great. So what will be the complexity of that if we do that? Yes, order of n square. Perfect. So now, so let's take an example case and try to explain this because all of you may not know this brute force also. Let's suppose a target is 8. That means we need to find the indices that sums up to be 8. Okay, and the array is 6, 1, 5, 3, 9, and here 7. Okay, suppose this is an array, and you need to find suppose here let's try to find all the indices that sums up to be 8. Okay, so we need to find two indices I and j, and ai plus aj equal to target. This is our goal. Okay, so what the brute force method that you guys are suggesting is, so let's fix this first one. Okay, let's make I is equal to 0 first, and I will search for the j such that this condition is satisfied. Okay, first I is equal to 0 is fixed, and now I will check. j is 1 is satisfied or not. Like 6 plus 1 is equal to 8, it's not. So I will check for j is equal to 2. Is that okay? 6 plus 5, it's 11, and 6 plus 3, it's 9. 6 plus 9, what is that? That's 15, and then 6 plus 7 is 13. So for I is equal to 0, I didn't found any element. I mean, I didn't found any j, so I can move this I to here. Okay. So now for 1, what are the things that I get? So for 1, I can try j is equal to 2, j is equal to 3, j is equal to 4, and j is equal to 5. Is there any possibility that I can get 8? I can get. If I is equal to 1 and j is equal to 5, so ai plus aj is equal to 1 plus 7, that equal to 8. So one output will be 1 comma 5, two indices. Okay. And if the question is asked in that way, you need to output all the possibilities, then you need to go forward, or else you can just break the loop here. Okay. Do you guys got the brute force method? What I taught? Okay. So here, yeah, I is not equal to j, because if I'm taking I is equal to 1 and I'm starting j from I plus 1 only. Here, the condition is uh, in the inner loop, j is equal to I plus 1 and j less than n. If n is the length of the array, then so that's what I'm checking. Okay. So there's a brute force method. Okay, cool. Uh, Now can we optimize it to n log n? This is n square method, right? This is n square method. Can we optimize it to n log n? Can we do that? So we can do that by using the two pointers that I will discuss now. Okay. Wait, 615397, right? Okay. So this array may contain negative values also. Negative values also possible, but I took for simplicity positive values only. In the question that they mentioned that each element is from negative 10 power 3 to positive 10 power 3, so it may be possible anything. What the algorithm that I am suggesting with the help of two pointers is, first let's sort this array. Okay, this is the first step, sort this array. Now what that becomes? 1, 3, 5, 6, 7, and 9. Right. Now I'm taking again two pointers, P and Q. So the P is pointing towards the first element and Q is pointing towards the last element. Okay. Right. So P is towards the first and Q is towards the last. Now this is sorted, right? Uh, what is our target? Our target is 8. Check this is possible or not. Uh, what is that? 1 plus 9, that is equal to 10. So this 10 is greater than the target, right? Okay. uh, what happens if I move p forward? I mean, what is the effect on this term if I move this p forward, and what is the effect of this term if I move q to the left side? Okay, two questions here I'm asking you. So what happens if I move the pointer p towards the right, and what is the effect on this ap plus aq if I move this q towards the left? No, is using two loops can be called, no, it's not a two pointer method. If we increase the p, the sum will be greater. Yes, that's cool. And if you decrease the q, that means if you move the q left side, okay, that will decrease the sum, right? How it is going to this is happens is, as this is sorted, if you move forward, you will get a value that is greater than 1, right? this is obvious. If you move forward, you will get the value 3, 5, 6. These are all greater than 1. And if you move q to the leftwards, you will definitely get the values that are less than 9 only, because 9 is the highest element. Okay. So what happens is, if you move p in this way, this ap plus aq is going to increase, and if you move q this side, ap plus aq, okay, is going to decrease. Here, our sum AP plus AQ is greater than target. Now, which I have to move is P or Q? Yeah, this is yes, yes. Order, as you said, the complexity is order of n log n plus order of n. So it's approximately order of n log n only. So here I need to move this Q, because the sum is greater than the target. I need to here decrease this sum. So I'm just moving this Q to here, right? Now again check what is the value of AP plus AQ. So 1 plus 7, that's 8. And fortunately we get the target, and so in two iterations only we completed, because if the question that I have shown you, they just need one instance of this. If they are asking multiple instances, then we need to go forward, or you can just stop this. Okay. Okay, suppose the question is we need to find all the possibilities. Okay. So one thing that we found is 1 comma 7. Okay, 1 comma 7, that gives 8, right? So this is a one result. Now at this point, so I need one positive. So I'm moving this both p and q. So now p is here and this q is here. I can check 3 plus 6, so that is 9, and that is greater than target. Now what I have to do here? Okay, sorry, this is q, right? So here again 9 is greater than target. I need to move the q. So q comes here. Now 3 plus 5, that is equal to 8. So another possibility is 3 comma 5. Okay. Now if you do that, now q comes here and p comes here, right? You need to increase both p and increase the p and decrease the q if you found uh, the one possibility. And now you need to continue this process till uh, p less than q. Okay, because they told p and q, that means the two indices must not be same, right? And you already traverse these two things, so you just need to check this until p less than q. So is this understood? Let's do some problem by using, I mean, we just optimize this from order of n square to order of n log n. Okay, because any built-in sorting function, sort function, that will take order of n log n, and for traversing it will take order of n, so it's approximately equal to order of n log n. Okay, because the degree of this term is higher, so yeah, for larger values of n, so the complexity we can write it as order of n log n. Okay. uh, so this is a somewhat we made it efficient than this order of n square. Okay, so you got this two sum, right? What if every element in the array is equal? Then there will be no answer. Actually, they asked for two different indices. They didn't told that. Suppose I got your question, Samit. Suppose sum is 4 and you have this thing. Okay, all are 2, and this is one possibility, 2 comma 2. I mean, these two are two different indices, right? And you just move this p and q. This is another possibility, and again you moved here. So there are three possibilities out of here. Okay, three pairs that you can get with the different indices, and that sums up to be yeah, the target. Did you get it, Samit? Okay. Any questions from this two sum? How I applied this two pointer concept in this sum? But there will be NC2 possibilities. Why? Why that so? Why NC2 possibilities? because we are not coming back, right? Once we move forward, then we are not coming back. So if everyone is comfortable with this, we can just move to threesome threesome problem. So the threesome problem is just the extension of this two sum. Okay, we can just go to threesome. Okay, see that sum. Given an integer array nums, return all the triplets, uh, I mean three values. Okay, and that sums up to be zero. Here target is fixed. Before the target is there, that the value that they given, like that may be anything. But here the target is zero, so that is not an issue. Okay, uh, and these are the sample test cases. Here also the array isn't sorted because they didn't mention that. Okay, so again, like before, can anyone suggest the brute force method here? And the brute force method, and what will be the complexity of that if you apply it? Yeah, three loops, and the complexity will become order of n cube. That is a brute force thing. So what you are doing is you are just fixing two values and checking for the third value. I mean, is there any possibility or not? Then that will become that. Uh, Take one element and find other two using two sum. Actually, that is the thing that I'm going to explain now. That is a very efficient method, and so what he suggested is very like he thought in very correct way. So if you apply this in brute force, that will take order of n cube, right? You need to maintain three loops, so it will take order of n cube. But what you can do is, if you fix one element, and for other two, if you use two pointer, I mean the two sum method that we discussed before, then what will be the complexity of that? Okay, so order of, so here there will be a one for loop outside, and inside you are using this two sum technique. Okay, and uh, so what is the complexity of this two sum? So that is order of n log n, and you are applying this n times. Okay, so yeah, okay, let's do this or in this way. Okay, first consider overall array, and for sorting it will take order of n log n, that's for sure. So the complexity is order of n log n plus, for n into, you need to traverse here, so n. So the complexity is n square plus order of n log n, so the total complexity is order of n square. So you drastically decrease this complexity of order of n cube to order of n square, and this is a very efficient way. Okay, you know, like from n cube to n square means it's a very high optimization that you did. Okay, the brute force method takes order of n cube as you did before. uh, Take three variables I, j, and k, and fix two and traverse the other n times, and again change the I, so I can change the j and again check for k. So this will become order of n cube. That is very normal brute force thing, and you will get easily TLE in CP problems, because in CP we usually need to find the solution that is a optimized or efficient one, not the normal brute force thing. And by using this two pointer method, this two sum involves two pointer method, right? And for the outer thing, uh, n times. Okay, did you got this? How you are going to solve this threesome? 1 minute. Hello. Okay, so did I need to explain this, or you guys try by yourself this one? Take it as a challenge and try to solve this in lead code. Okay, you guys got how to do it that do something. Yeah, you can do, because great. So threesome is also okay, right? So can I move forward to the next question? Yeah, you will get the assignment, but I think these problems won't be there in that. All the problems were said by Roshan. He usually collects the problems from code forces. I think these won't be there, but you can in lead code you can find the problems under each section, right? There will be two pointers, greedy, ad hoc, everything will be there, and you can just go there and you will find a lot of problems to solve. Okay, but you will have a assignment this week. Today, this after this class over, I think you will get the assignment tomorrow or day after tomorrow, based on these three topics. Okay, now the next thing is finding the middle of the linked list. We have two things remaining. If we can complete those two, then we can just wrap this up because this is a very short session. The one thing is middle of linked list, and the other thing is pair programming. This is a okay pair programming. Let's discuss further after this completion. How many of you know about linked list, and how many of you know about linked list, or no one knows about it? What is a linked list? Because here there are a lot of people who are from first year, so they might don't know about this. So that's why I'm asking. So I will just explain brief. Okay. What happens in an array? uh, an array is stored in a memory in a contiguous blocks. Okay, suppose if you have a 5 elements in array, those 5 elements will be stored one after another, okay, in the memory. But uh, there are some disadvantages of arrays. So one is insertion and deletion. Suppose you have 1,000 elements in an array. Okay, uh, so a0, a1, and so on till 8,000, and you need to insert an element at the starting. Okay, what you have to do now? So you need to move all of this, okay, these elements forward, and you need to create a space at the beginning, and just you need to insert that. So that will take a lot of time. So okay, it will take order of n time for insertion. And similarly, if you need to delete this, you need to move all of things before. So that will also take order of n time for insertion and deletion. So these are the disadvantages of arrays. Now to avoid them, so there is a one option, that is a linked list. What you do is, a linked list is a structure, or it's a pair. Okay, it's a data structure that you have to learn it. Okay, it consists of two fields. One field will contain the data, I mean the value that we're storing. Suppose in an array we have elements like 3, 4, 2, 1, 6. So this 3 will be stored here, and next again there will be another thing that will store 4, and this will link to this. I mean this field, whatever I'm pointing now, this field will contain a pointer to this next element, and this will contain the pointer to the next element, that is a 2, and this will contain the, so this will be the linked list. Okay, I can just write, I will write it neatly. So this, and this is 3. Okay, this is 4, 2, 1, and 6, and this is linked to this, and this is linked to this, and this is linked to this. Now what about the last thing? It will null. I mean null means uh, it is the end of the linked list, and the first element is called the head, and the last element is called the tail, and actually this thing is called the linked list. Okay, did you got briefly about linked list, not perfectly? Okay. Actually, Morris Traversal, I didn't heard about it, but yeah, I can tell you after. I can reply you in Discord about this. Okay. Did you guys got the basic idea of linked list? Not the whole thing, because that's not our purpose. But okay. So actually, what happens in a linked list is we have for each and every element we have two fields. One will contain the data, and the other will contain the uh, pointer to the next element in that list. And what will happen? What's the case for the last element? It will just contain the null element because that's the end. Okay. Now here you need to find the middle of the linked list. How do you found that? Okay. How do you find the middle of the linked list? Okay, suppose if the array is given, how did you find the middle? Okay, it's a very simple question. If an array is given, how do you find the middle element? Yeah, size by 2. You can just reply array of size by 2. That's the middle element. It's very easy. But what about linked list? Is that here? Is that possible? Like indexing is possible? Indexing is not possible. And also one thing is random access is not possible. Okay, so if you want to find the third element, you just need to traverse these things. I mean, you just need to take a variable and you need to move it forward. You need to move it forward and go to three. I mean, go to two. Okay, so this is what. So in linked list, the major disadvantage is random access is not possible. Okay, uh, so you can't do that a of size by two. And moreover, how do you find the size? How do you find one move, two moves at a time, and the other will move? Yeah, that's the solution, Samit. Actually, that's what I'm going to explain now. But anyway, yeah, how to find the size of the linked list? How many elements are there? So I need to go until I reach a null. So that will take order of n, right? And after finding the size, I need to again move to the half of it, right? So that will take again order of n by 2. Okay, it will, I mean, I need two traversals for it. It's a efficient only, but I need two traversals for it. So what happens if I uh, ask you, can you find the middle of the linked list in one traversal? So 3, 5, 2, 7, 4. So this is a linked list, and these are the links. Now I need to find the middle of the linked list in single traversal. In two traversals you can find easily, because in one traversal you just find the size, so size will become 5, and you will do 5 by 2, that's 2. Okay, uh, now as you have to take the seal of it, so it will become 3, right? Now you just need find the third element, that is equal to 2, you just return it. So but what you did is you just traverse this two times. Now I'm asking to find this in one traversal or single traversal. Okay, so any idea? uh, Moving two steps reach null, we will stop one. Okay, so that I will discuss now. Size plus plus until null. Okay, this is for finding the size. You got. Okay, so the solution is what Samit wrote. That's the thing. One will move two moves at a time, and other will only one move. Okay, so that's I will explain now. Okay, see this thing. So again, take two pointers, P and Q. Okay, so one will point to the first element, and another will point to the second element. Okay, now at each step what I will do is, so while q is not empty, q is not equal to null, I will move p forward, and at the same time I will move q two steps forward. Then what happens? So p comes here, and as q is previously at 5, so q comes here, right? So now q is at here. Is q is not equal to null, right? Q is null or not? it's not equal to null. So I again move forward P. Okay, Q comes here, and I need to move 2 times. So Q comes here. Okay, now Q is null, right? Because there is nothing here. So Q is equal to null here. At this point, whenever we found that Q is equal to null, what you have to do is uh, you just return whatever the value present at this P. Okay, so the middle is 2. So you found the middle of the linked list in single traversal only with the help of 2 pointers. So one pointer is moving at 1x speed and the other pointer is moving at 2x speed, and you found the middle of the linked list in single traversal. So this is like this question may be asked in interviews. Okay, the normal thing is uh, you just find the size and return size by 2. But if you do this in this way, it's very I mean a logical thing. Did you guys got what I said, or I need to explain this again? Hello. Okay, Samit, you got it. Okay. Any others? So there are other people also. You also have to reply because it should be interactive this session. Okay. One challenge for you guys. Try it. So try to find kth element from the last in a linked list in single traversal. Okay. Try by yourself. So it that will also involve 2 pointers. Okay. The question is find the kth element from the last in single traversal. Okay. Did you got the question? So try this. If you can able to solve, that's great. Any question you can just post in the Discord. Okay, mentors are there to help you. Yeah. So two challenges for you. One is the trying the threesome problem and also this thing. And now only one thing left for today's discussion, that is a pair programming thing. So let's discuss that final thing. Do anyone solve this problem, pair programming problem before? Hello. Samit, did you solve this? Arnab, guest. Okay, don't remember. Okay. Okay, I will show the question now. So pair programming. So I will read and explain. Monocarp and Polycarp are learning new programming techniques. Now they decided to try the pair programming. Okay, actually pair programming is solving the questions together. It's known that they have worked together on the same file for n plus m minutes. Every minute, exactly one of them made one change to the file. Before they started, there were already k lines written in the file. Okay, so what they are saying is, before they started doing, there are already k lines in the file. Every minute, exactly one of them does one of the two actions. They can add a new file, new line at the end of the file, or change one of its lines. Okay, suppose there are 3 lines previously. Each person can do two things. Either he can write the fourth line, or he can just any of the he can modify any of the first 3 lines. Okay, Monocup worked in total for n minutes and performed the sequence of operations. So in each and every minute, Monocup is doing one action. So those actions are A1, A2, and so on an. If if AI is 0, that means he is adding a new line at the end. Okay, if AI is not equal to 0, that means he is just modifying the line equal to AI. Okay, then he changes the line with the number AI. So Monocup performed actions strictly in the order A1, A2, and so on an. So he did in this order only. That means he didn't do that in first A3 and then A1, then A5. It's not like that. He first did A1 and then A2 and then A3 and so on. In the similar way, Polycarp worked in total for m minutes and performed these operations. So same thing, if bj is equal to 0, that means he's adding a new line at the end. Or if it's not the case, then he's just modifying the line that is equal to bj. Okay. uh, Restore their common sequence of actions of length n plus m such that all the actions would be correct. So what you need to do is you need to merge these two arrays, first array A and second array B, such that the process will be possible. Right here, not uh, like merging two sorted arrays. I mean, it seems like that, but it's not exactly that. You just need to arrange them. I mean, you just need to insert values b1 to bm in between a1 to n, or a1 to n in between b1 to bm. Okay, so there should be no changes to lines that do not yet exist, keeping in mind that in the common sequence monocarp actions should form the subsequence, and polycarp subsequence, they can replace each other at the computer any number of times. Okay, if there is no combination possible, you just need to print -1. I will take this and try to explain this. Okay, so what is the input there that they are giving? uh, K, that means the initial number of lines, and the length of the arrays. So I'll just take 5, 4, 4, and what are the other things? 6080. Okay, and the other thing is 0709. Okay, these are the operations that are performed by the first person, and these are what is the name? Uh, First monocarp, right? So these are the operations done by monocarp, and these are the operations done by polycarp. Okay, 6 means he modified the line number 6. Okay, 0 means he added a new line. 8 means he modified line number 8. 0 means he added a new line. So in this way also, same thing, you can interpret it. So you just need to arrange that such that this thing is possible. If you found any contradiction, then you just need to break that and print -1. So I will explain this solution right away, but because you can understand this, uh, I'm taking 2 pointers again here. P is pointing to this 6 and Q is pointing to this 0. Okay, and now uh, whichever is smaller, that means whichever smaller means I'm looking for 0. Okay, my goal is always to increase the number of lines. What is the contradiction? When will this contradiction arise? Is if I have only 3 lines and there is an operation that he modified fifth line, that means this is a contradiction, right? Then only I need to print -1. Is this point understood? So suppose I have only 3 lines and I try to modify the fifth line. Uh, so that is a contradiction. In that case only I need to print -1. So that's why my goal is always to increase the number of lines. So I'm just looking for any 0 is possible or not. Okay, so if there is no 0, then you can do anything, right? So here uh, 0 is there, so number of lines will become, now k will become 6. So move the q forward. Now p is at 6 and q is at 7. Now whichever is smaller, so p is right. That means you have 6 lines and it is possible to modify the sixth line. So it's cool. Now you just, now what is our answer here? First is this 0. Okay, now what is the second operation here? 6 that you are doing. Now move this p to 0. Again check for 0 in this p2 or whichever is smaller. So here p is smaller, so now that means increase the number of lines. It's 0. uh, P comes here. Now check for the smaller out of 8 and 7. So the smaller is 7, right? Okay. So move that q to here. Now this is 7. Again you look for 0 in between 8 and 0. So you have 0. Now it will become 8. Okay. So that's 0 and move q. Okay. And then out of this 8 and 9, so what is the smaller? This is 8, and 8 is possible, right? So you can just do that. 8. If you found any contradiction, you just right away break the loop and print the -1. That's obvious. And now move the forward p. What is the smaller out of this? So that's a 0. Now the number of lines will become 9, and 9 is possible. So 9. So if you, this is a one possibility that you can do, then you will able to arrange them, and you didn't found any contradiction. So this is a one answer. If they can be multiple answers, but you can print any of them. So what I'm doing is I'm taking 2 pointers. So I'm looking for the smaller one, and I'm checking enough number of lines are there or not. If the enough number of lines are there, I'm adding that operation to my answer. If there is no, suppose you have um, p is pointing towards 5 and q is pointing towards 3, and you have only 2 lines in the file. So even the smaller is 3, but you have only 2 lines. So that is a contradiction. That means you have to print -1 because you can't do anything. Uh, because you are not allowed to interchange the operations that they did, right? So the solution, you understood the solution, right? Or do I need to explain it again? Yeah. Okay. So try this out. This using 2 pointers only, and this involves somewhat greedy. That means you are looking for the smallest one, right? So best possible thing at the time. So that's why it involves greedy. Okay. Yeah. So it's all about 2 pointers, and you will get the assignment uh, related to greedy, ad hoc, and 2 pointers. Try to solve this, and yeah, all the best. Any questions? Any general related questions? I'm just stopping the recording.